right? So that if, yeah. So now let's say, those are those services. Let's say I want to connect to a particular service. Okay, so I'm going to do that next. I'm going to say, okay, I want to talk to a certain server. So I'm going to create a variable here called server, and I'm going to assign it the value. So this, in most programming languages you would say equals here, but in R they like to do the kind of, this is the way of assigning a variable. You can use equals, okay. But this is the typical way.
This is the R way.
This is the R way. I guess you could use. So I'm going to type this out. You guys can double check me to make sure I'm typing it right.
Ooh, no T.
No T.
I went for a switch. I don't know what switch is. So we're talking with, this is the CUAHSI 1.1 version. You can see that's the 1.1 of the web service. And WSDL is a standard, a web service definition language standard that's defined by SOAP. So much larger than CUAHSI. It's kind of the a standard web service description.
You got extra S. That S on this.
Thank you. Okay. So all I'm doing there is taking that text string and assigning it to server. Okay. So that's the server I want to connect to. Now let's say I want to, now I looked at the catalog, I saw all the servers there. Now I'm going to say, actually I'm interested in data from this one particular server. And I'm going to ask the question, what variables are available on that server? So I'm going to say variables, and I'm going to say get variables. And I'll get the variables from the server. Stop me anytime you have questions. And you'll get a message back. It's good when you see success. If there was some kind of issue, it actually tells you, it's kind of nice, tells you whether the issue happened on the client side, on the server side. So if the server, for example, doesn't support that get variables call, you might see a server error. If you type if I type the server name incorrectly, you might see like a client error. So you can kind of helps you a little bit with tracing back the errors. All right, so I went and got the server. Now let me get the sites defined there as well. So what sites are available from this server? Okay, we got those as well. All right, so we can go and look at those. So if I go back over here now in my R environment, and let me, so you see I just made two new variables. One's sites and one's variables. So if I click on the variables, so we see this is the metadata essentially. So we have something called a variable code that uniquely identifies what the variable is.
So it's 3 observations of 16 variables. Is that what it means?
So we have 3 different. So on this server, there are 3 different variables that are being observed, that have been observed, and so all the data values on that server, there's 3 different types of variables. All right, and there's 34 different sites.
And the 16 refers to?
Yeah.
Yeah, I'm not quite sure what that, where it says 3 of.
Oh, 3 of 16.
Yeah.
Because I thought there's like 16 columns.
Yeah, this says it's 16.
Yeah, that could
Yeah.
be. That could
That
be.
is it.
But then that variable should be 3, right? There are 3 variables.
Well, there's 3 variables.
Right.
So it's 3 rows, but
There are
16
3 rows and
columns.
16 columns. We could count that out to see. Yeah, right. So let's test our theory.
Yep.
34.
34.
Who wants to count?
We got 6 up to 1, too.
Okay.
10. Yeah.
Done.
Yeah.
Good job. So it would be nice if they said, well, that makes sense. 3 observations, and for each there's 16. I mean, in some ways it makes
Yeah,
sense.
it
There's
just
16
reads
variables
funny.
describing.
Yeah.
I mean, I would like to see 3 rows and 16 columns, but.
3 variables.
Or 3 variables, right?
10 attributes.
Something
Yeah, I
like
don't know if that's something that our studio is doing, or is that something on the WaterML side
I
that
don't
could
know,
be
I'll have to
redefined.
note that in the
Yeah,
documentation
yeah.
for sure.
Cool. All right, so we got these. So we've got 3 different variables that are being observed. Again, temperature, DO, and then DO % of saturation. And then back to what John was saying, this is stuff from the observations data model largely, which is all the metadata that you have to know. For example, what's the sample medium? These are observations within surface water. What are the units? What type of unit is it? So on and so forth. Okay. And then the actual sites. So we have 34 different places that these 3 variables were measured. Each place might be measuring one of these variables. And actually, so each site might be measuring one or more than one of these. Each site has a latitude and longitude. It has a name. It has a county. It has a state. Okay? Any questions up to this point? Okay, cool. All right, so what we're going to do next is we're actually going to go and get, for one of the sites, I'd like to get a little more metadata about it. So to do that, I'm going to do a get site info call. So for one of the sites, I would like to get more information. Get site info from this server, and then now I'm going to give it the full site code. So this is from the full site code column.
So the full site code, the difference between site code and full site code is site code, the data publisher identifies and creates. The full site code is a concatenation of the, basically an abbreviation for that data service and the specific site code. So IRWA is Ipswich River Watershed Association.
Right. And then instead of clicking on it over here, the way that the tutorial writes is you actually say a command here saying view it, and then it puts it up on that screen. It should put it up on the same screen. Right. So what this actually did is it went and got that one site. It actually returns 3 things because there's all 3 variables being measured there. So this is getting down to like what's being measured at each site is returned from get site info. So I've learned now that DO, %DO, and temperature are all being measured at this site. And now it gives you additional metadata. We get all the way down to like what method is being used to measure it. So this matters a lot. What instrument are you using? What lab analysis did you do? How many data values were observed there? So now we have a little bit more information about the time series as well. So we have 22 observations that began in 98 and ended in 01. Okay. All right, so we've learned about the site as well. So now let's go and get the actual values. So for this site, I want to go get the temperature values and then the DO values. So to get the temperature values, I'm going to define a variable called temp. I'm going to use the get values call from that WaterML library. Now I need to tell it 3 things. I need to say what server I want to get the values from. I want to say what site to get the values from. So the same site as before. And then I want to tell it what variable code to get the values for. I'm going to get the temperature. Oops. for this one. All right, so it doesn't take that long. I mean, there's only, how many values do we say for temperature? 22 or so. So if you had a time series with, a couple thousand, you might sit there for a minute, while it downloads. So basically, we just downloaded all the values. So I'm going to do the same thing here, except for now I'm going to do it for DO. All right, so now I have that DO time series down and loaded into this variable. Okay, we can go and view those. You notice that we have new observations here. So let's just go ahead and view that temp variable I just made. See what it looks like. So we have basically just straight time series, the time and the values. Right, and the time is ISO time. Okay, so next, let's plot these. So I'm going to do a plot of the temperature. And I'd like this to be colored red. And here in our studio, very nice, just kind of figures it out that I want time on the X. I didn't actually tell it that. I kind of figured it out. You want time on the X, the actual data value itself on the Y. Now I'm going to put on that, I'm going to use this command points to add onto that existing plot the DO. I'm going to make those blue. Okay. So now we've got a nice plot here of the DO and the times and the temperature time series. Okay. So now let's say we wanted to actually do a plot of DO versus temperature. So to do that, first we're going to do a command in R to take those two time series and merge them together into a single table. We want to have the columns be time, DO, and temperature. So the way you do that in R, I'm going to create a new data set. I'll just call it data, for lack of a better word here. I'm going to use a merge command. I want to merge the DO variable and the temp variable, and I want it to be merged using the time column as the common column between the two. So if you have, if you didn't measure DO and temperature at the same time, it's going to handle that, right? But when you, okay. Yeah, you need an equal sign right here. Okay. So if I want to go through and view that, it looks like this. So time, data value.x, data value.y, which isn't super nice. So if I want to change those columns, I can say, okay, change the names of that data object, and instead make the column names time, and then DO, and then temp. Right? And then there you go. Now we've got nice column names. We have time, DO, and temp. All right. So
values don't overlap. Just throw a no data in one.
I think it'll do like a missing, whatever the missing value, like a no data exactly. Okay, so now let's do a plot of this. So we just say plot this data, please. And I'm going to say plot the DO versus temp.
I think it reduces, right? The number of data points instead of doing no data.
Well,
Convert it to
we
19.
yeah, I mean we
Instead of 22, we have 19 observations.
yeah, we can go back and see whether it looks like they maybe did it only when they're in common. And there's probably ways of overriding that.
To no
I would
data,
imagine
yeah.
in the different parameters there, say, because you're probably you're doing basically a join.
Right.
Do you want inner or outer, or,
Mhm.
that type of stuff. So, sure. Okay, so here's our new plot of DO versus time. Yeah, that definitely looks like it could use a linear regression, right? Okay. This is the part where the simplicity of the model of the tutorial kind of breaks down. But let's just assume that's a nice linear. It's somewhat okay. Let's fit a linear model to that. So we say model, a linear model, and just to make sure I know this goes without saying, but R can do a lot more than just linear models, but for the sake of time, we'll just do this. DO versus temp. And the data that you want to use for the model, they just name that. The tutorial just names it data, so it's kind of data equals data is kind of a weird thing, but that's what's going on. All right. So we can actually print out a summary of that linear model. All right. Right, so different coefficients for that linear model, and actually gives you some error measurements for that linear model as well. The R squared value you can see here, helps to tell you that's not a great model. Okay, and let's just say we wanted to make a plot of this. We can use this AB line, which is plot a straight line, and it actually will take in that model variable. So add it to the existing plot here, our straight fit line for that data. Okay, so that's the tutorial. So I think the things to emphasize here are, when we first kind of envisioned this CUAHSI, one of the big motivating factors was to get the user interface out of the way, and that user interfaces are super helpful a lot of times, but sometimes you just want to get direct access to the data, and so this is a nice way to demonstrate that. You can just directly call and get access to the data, and you could do it in any programming language, right? Because we're following standards, and there's a lot of while we're using WaterML package library that our group, the CUAHSI group created, it just provides a little more convenient way. That would have taken a lot more lines if you went straight with the web services. You could still do it, right? But it would take a lot more lines of code. So that package just makes it a lot prettier, a lot simpler. Okay, that's one thing to emphasize. And you can point it to when we did at the very beginning. Remember, we got 103 different services that are. So I could do a similar thing and just changing this URL to a different service. So if you wanted to get access to the NLDAS data, for example, you would just switch this URL that you're pointing to that one, and now you could do the exact same thing in some sense, get values, get sites. That's a huge data set, so it'll probably take a while to, some of those calls might take a couple seconds to return.
Can you be logged on to more than one server at the same time?
Yeah, so you could definitely have a variable server 1, server 2. I could rename that, this IP switch, or whatever it is. Yeah, I want to say switch. Server. So you could have 100 different servers connected to it once and kind of gathering, getting your data. I think this is super nice for kind of reproducibility in some sense, because you're going straight to that data source, and then you do all your analysis. You can imagine your code being like, okay, get the data first, and then do your analysis all in one script. And now it's kind of, you give it to another colleague, right? They just run that script, right? Because it's reading, as long as they have an internet connection, they can reproduce that script. You don't have to give them the data as well. It opens up some issues, though, of course, right? So what's the guarantee if I run this exact thing? If I run this again tomorrow, what assurance do I have that it will give me the exact same result? Well, I don't control that data, so they could make adjustments in there. Oh, wait, we messed up this measurement. It shouldn't have been, 8.1. It should have been, 9.1. Someone entered it wrong. So I think it's a good practice kind of you might think of it as a caching stage. So like the web browser works, when you go off to a website, it actually copies down a version of that locally. so that if you go and visit that site again, it actually goes to the local version of it. So I think it's a good strategy to have some caching built in, where you can say, okay, I'm going to go get the data, but I'm going to put it local, so I know exactly what data set this is based off of. So you can have two phases almost, like a fetch all your data part, and then it writes it down to a local directory, and then do your analysis off of it. And if you need to go refetch it, you can do that, and you can see the different versions from the different times you went and fetched the data. So that's what we've done in a lot of our analyses, that type of approach, kind of a caching, intermediate step. So, yep, that's pretty much the R tutorial. So,
do you guys have any questions? Or, I mean, that's basically all that we had. I mean, the handout that hopefully everyone has, if you don't, I have more over here, has kind of an overview of everything that we touched upon today, as well as contact information for myself, John, as well as Yuri, who's the guy that developed the R package. So I got my email up.
yeah.
But yeah, so that's.
Yeah, and you can publish, if you collected your own data, you could publish it using what John was showing, and then do your analysis in this environment, reading your data in from your services, and have everything nicely synced up in that way. That would be.
And I should say everything that we talked about today is free and open source, and even the hosting stuff for US researchers, especially NSF funded, everything is free.
Is it hosted on an S3 server right now? Or
So it's hosted, the time series data is, so actually everything's hosted in Azure, in the Microsoft Azure cloud.
Okay.
We use, for the GIS data, we use Arc Server.
Can you let people use that who aren't on NSF projects? There was a little modification.
So right now we're in a stage where we don't really have our business model per se really refined. So for sure we're mandated for any NSF funded project that we'll provide all of our services for free. We've been discussing with some of the other federal agencies how that might work, or how CUAHSI might get some support from those agencies to basically provide the same sort of services, but to kind of a different community.
Yeah, there's the issue, long-term issue here of what happens when these data sets get really large, and who's going to pay for hosting them. That Rick Hooper, the president of CUAHSI, is concerned about, right? So there's different models for that. I think you can actually, with S3, so Amazon Web Services, they have a lot of different tools, if you will. One's called S3, which is this storage resource, and they will give you free space if you kind of write a very short proposal. Very short, it's just what you want to do, or if you want to make your data open and public. They're very supportive of science communities, so that's one way. And the amount of data we're talking about to like Amazon is probably not a lot of data, right? So that's one potential way. And then Rick's really pushing on the university libraries to be the folks that long-term maintain this data. Because when we get a grant from NSF, the University of Virginia likes to take 58% of it as their overhead. So in some sense, there's some obligation on their side to be the long-term data hosting. So we've had some conversations. I've had some conversations with my librarians at UVA. But there's a lot of finger pointing about who has the responsibility for long-term maintenance of this data or storage of this data.
Are you getting any reception from the librarians?
Yeah, they're definitely. They understand that this is an important thing and a mandate and probably a good opportunity for them, but they're also kind of nervous. It's not their traditional business model. Right. They don't really think about. They're starting to think about management of data sets, and usually when they think about that, they're thinking about like, someone went out and did a survey or something. So an Excel file or something like that. They're not really thinking about terabytes of model output. So they're a little scared about that. Yeah. Right.
So on the Arc server side, so is that a function of just for the personnel resources that you went with Arc server vice like opposed Postgre?
Yeah, I think it was lowest barrier to entry, I think, in
Right,
some
yeah.
ways with the staff that we had, because that was kind of the expertise that we had on staff, and it's worked out so far. I don't know if it's going to scale,
Right.
but for now, I think it's been adequate.
And you can also publish that as a web service, like
Exactly.
RGS Online.
Yeah.
kind of
So
a-
one of the dreams that I have, for example, right? So those are all put out as web services. So what happens when we have this web client? Why can't I pull in my study area from the spatial data service, right, natively into the web client, and then perform any more searches or whatever, like that. So right now I showed that slide about the ecosystem. A lot of the tools are still kind of separate. And I think over the next 1, 2, 3 years, a lot of work is going to be to tightly integrate those. And I mean, you can kind of see some of that already with the HydroShare project that John talked about.
Yeah, yeah. So I think that with NSF's mandates and other funding agencies saying you need to care about your data management, this is a forcing function for scientists to think it through. And I've heard stories, at least from folks that served on panels, and how much the reviewers take into account the data management plan, whether they just kind of ignore it or look at it closely. It sounds like it's starting to get to a point where people are looking at it much more closely and making sure it's a really solid data plan. So I think what CUAHSI provides is a really nice, I'm going to publish my data in Hydra server. If it's time series data or GIS data, it sounds like that's a pretty solid data management plan, because you've pushed the maintenance to them, and you just simply have to upload it. And we're migrating. A lot of the data management plans are all basically, I'm going to put it on my own website, and those aren't good enough anymore. People are calling those out as being that's not sufficient. So I think that you have, it's like a carrot and stick thing, right? So how do you get scientists to care about data management? Well, if NSF says you have to, that's one way. Right.
Can I extract, I know I can do this in Google Maps, where I can write an API and display data sets on the map, make it scalable and things like that. Can I do the same thing with our server? I don't know of existing APIs that talk to each other with Google Maps. And
I'm not too familiar with those APIs.
Well, there's an API for you could basically, you could write your own ArcMap website using the API for the catalog to go and query what are all those sites within this bounding box, and then display them. And then for each site, you could have a little link say, go get the data. When you hit that data button, it would go off and hit the Water OneFlow services. Absolutely. There's nothing stopping you from doing that.
But they have
Other than
a
time.
limitation, right? Every time there is a viewership, there is something that they give you. There's an allocated viewership. So if there's 10,000 views or something, you run out of, I don't know what they're called, but
Right.
Yeah, that's what brought mine.
Because in
spawned
Google,
my
you don't
question.
have that limitation where you can actually just pull on a map. You don't have a limitation in terms of
Well,
viewership.
Google does have limited. Well, they
No, not-
start charging you.
No, but for an educational, they don't have. Yeah.
Yeah, for the Google Maps API, we should be golden.
I was just curious about whether or not you can pull it in Google Maps or something like that. But
I don't see why not. To be
Yeah.
honest with you, I think it's.
Because it'd be
because you
so-
could add your own asset from Google then on top of this. So if you have fusion table data, for example, the same data in fusion tables,
Yeah.
and if you have raster data in Google Earth Engine, you would be able to add it
So
on top
yeah,
of this.
to me, this is the real potential. Is this the service-oriented architecture? It's
Yeah.
all open. You can go in and do what you want with it. You can mash stuff up, and
Sure.
And so I would love to see more kind of creative things like that happening, from folks just kind of grabbing it, and it would be really cool to feed it back to CUAHSI as you could have a page or whatever of different examples
Right,
of how
right.
people have used this for their own
Mhm.
benefit. Because I think while we originally envisioned it as this the client is open-ended, it could be R, it could be MATLAB, it could be Python,
Right.
it could be whatever. It's kind of gotten, the story's been for a while at least, it's Hydro desktop only.
Yeah.
And so I think we're opening it back up to saying there could be unlimited number of clients that are kind of.
Most of
building
that
off
is
it.
I mean, what's really driving it, I think, is the adoption of all these standards. So WaterML, that getting adopted and people actually taking it seriously, and then stuff like the sensor observation service profile. I mean, these are things that a lot of people are adopting and making it a big playground.
I think and there are so many things you could do with like the API, for example, the geolocation API within Google. You can just say, I want to find out about all water stations around me within a 10-meter radius or 10-kilometer radius, for example. And you can script that much easier than, I've never done it in ArcGIS server API, but I don't know.
Yeah, I would encourage you to do that in your spare time.
The
And
ArcGIS
feedback.
server. I've done it in Google. I've not done it in.
Okay.
Yeah.
I'd like to see if I can connect to it. Leaflet. That's my personal favorite.
Okay.
Web map.
What's it called?
Leaflet.
I haven't heard of it before.
Everybody uses Leaflet.
Apparently not.
Flickr uses Leaflet.
Okay.
No, so it's a really lightweight JavaScript library for
pretty good.
interactive web mapping.
Oh, cool.
Super simple,
Cool.
super nice. It makes really beautiful maps. Doesn't have, personal web mapping. If you do with Google,
Yeah.
and it gets hit by Slashdot or Reddit or something, quickly Google shuts you down because you win over your viewership. But so you don't have to deal with that. It's a completely open standard. Uses well, you could use any WMS or WFS server for tiles.
Okay.
Or you can just use OpenStreetMap.
That's pretty cool. I haven't heard of
That's
that.
cool. I've never heard of it either.
And there's a ton of extensions, plugins.
So I think our 2 hours is just about up, so thank you all very much for coming, and our contact information is right on the cover of that handout. So.
Yeah, if you do these cool things, let us know.
Yeah. Thank you. Thanks for coming.
All right. Yeah, it's what I fly out, man. You're like a wheeler and dealer, dude.